Morning, my beautiful people. Now we are the chemistry boys and we are going to talk to you about organic chemistry. My name is Jorge.
Hey, Mauricio.
Roberto.
Diago.
And in this video our objective is to show you how to name the alkanes, alkynes, alkenes and aromatics.
I think okay.
UPAC is a global organization that is organized to tell what name do the cycloalkanes have to have. Well, what is the importance about this? The importance is that with the name we can know how the alkanes, alkenes, and alkenes are formed. Also the cycloalkanes.
I am a chemical engineer and I will talk about alkanes. Well, first of all, you have to locate it along the chain. As you can see, there are 4 atoms in consecutive form, so I will take this. And I will number the carbon atoms according to the substituents, which are these. So we'll put 1, 2, 3, and 4. Okay, this substituent, like, it only have 1 carbon atom, and we call it methyl because of the prefix. So this compound will be named 2 because in the carbon number 2 methyl, and because there are 4 carbon atoms in the long chain, it will be called butane. But is a prefix, and ane because it's only cane. So it is 2 methyl butane, and that's the number of this compound. Now I will name new alkanes. Okay, first of all, you have to locate the greatest carbon chain. As you can see, is this one because it has greater atoms. It has 1, 5, and 6 carbon atoms. So I will mark this. It's graded because if we indicate that chain with the substituents, it will be less. So you have to count it, and in order that the less number will be in the substituent. Like here, it's 1 and 2, and if you start here, it will be 1, 2, and 3. This number is less, so I will start from this number. So it's 1, 2, 3, 4, 5, and 6. Now you have to seal. So what do you need? For example, is 2 because it's located in the carbon number 2 and located in the carbon number 4. So would you put 2, 4 and a dash? But like you have 2 different dimethyls, they will put the prefix, which is dimethyl. And like they are 6 carbon atoms, they will put hexane. And in this one, this is the longest carbon chain. Well, as are you saying, this and this, it's as you prefer. All numbers 1, 2, and 3. So you have 2 methyl again as substituent, and they are both in number 2. So would you put 2, 2, dimethyl again, and propane because there are 3. And the close. I told you about the inverse. You have the name and you will draw the chain. First of all, you have to recognize this of chain. That means that the longest chain will be formed of 8 atoms, of 8 carbon atoms. So it's 1, 2, 3, 4, 5, 6, 7, and 8. Okay, do you see 3 ethyl placed in the carbon number 3, and that's why it's my chain. I will draw that. I will prefer there's 1, 2, and 3. I will 3 ethyl. Ethyl, that means there are 2, so it will be CH3 CH2 3 1, 2, 3. Hold that 3, and it will be 1 because carbon has the 4 atoms. 1, 2, 3, and 4 because it's number 1. And the 2 and 6 I will draw a methyl. So here I will put CH3. It's 1, 2, 3.
Hey, mister, isn't this supposed to be a 2?
Oh yes, sorry. Because I'm confused. Thank you. Thank you, student. Thank you very much. And the carbon number 6, I will do 3, 4, 5, and this is my carbon number 6. I will draw a methyl again. CH3. This is the chain of this compound. And now, for the compound, this is a chain. That means it has 5 carbon atoms. So it's 1, 2, 3, 4, 4 and 5.
7.
Oh, a chain, so it could be 7. 1, 2, 3, 4, 5. 5. This and 2. 6 and 7. Okay, and the 2 I will put a propyl. A propyl is 3. Prop means 3. So I will put CH3, CH, and CH3 because it's 1, 2, 3, and 4. This is compound number 2. And
Teacher, isn't this an isopropyl?
a what? An isopropyl?
Yeah.
Yes,
It
student.
should be like this.
You were trying this.
Yes. I'm trying, if you're
Thank you,
paying
Lisa.
attention, this is very important in chemistry class. Millennial thoughts also. So, thank you for teacher, so I will put attention. And decaying, that means 3, there 10 carbon atoms. So, I will put here 1, 2, and you see in the third one I will put a tilde, so I will put this. Meanwhile, I complete the others 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and finally 10. And these field means that are 2 in the number 3. 1, 2, 3. So I will put C H3 and CH. Thank you, students. I will. Jorge, if this was correct, you are my students. You have to correct.
Let me see.
You see. I let you see. Don't worry. Yes, right.
Ah, yes.
I'm happy that my students are paying attention to me. This is chemical engineer, and it's the future of the world. Thank you.
Hi, my name is Roberto and I'm going to explain you how to name alkenes. Well, alkenes is very different from alkanes. Why? Because it involves double bonds. Indeed, here we got an example, and in this tutorial we're going to name it. Well, the first rule to name it is to identify the parent chain. The parent chain in this case, in alkenes, there always you're gonna be the one that has the double bond, and it's gonna be the more longer. In this case, obviously, is this. Why? Because it's the more longer and contains the double bond of the hydrocarbon. The next step is to name it, and in alkenes we're going to start naming from the side that is more closer to the double bond. In this case, is more closer here. So we're going to start naming 1, 2, 3, 4, and 5 carbons. After that, we're going to identify the substituents. In this case, we only have one substituent here in the carbon number 3. So in this case, the name of it alkene is gonna be 3. And because it's 1, it has to be the prefix methyl, 3 methyl, and then in alkanes it's gonna be the name of the longest chain. But here we have a double bond, and we need to specify where it is the double bond. and it's in the carbon 1 because it's more simple than put 2. So we're going to write 1, 1, 2, 3, 4, 5 carbons. You're gonna be penta. Pent in. This is the name of its hydrocarbon. And here we got another example of an alkene. And we're going to identify the parent chain and name it from the IUPAC rules. Well, first we're going to identify the parent chain, and obviously it's this one. Okay, and then we're going to start naming from the place that is more closer to the double bond, and it's the same for the both sides. So we're going to go to the substituent, and it's equal from the both sides. So it doesn't matter where you start numbering. So I'm going to start numbering from here. 1, 2, 3, 4, 5, 6, and 7 carbons. Okay. Then we're going to identify the substituents. The substituents are 2 carbons. Okay. Then identify where the substituents are, and they are in the 4 carbon. So it's gonna be 4 dimethyl, because they are 2. 4 dimethyl, sorry, because they're in the same carbon. And then the numbers where the double bonds are in the 1 carbon and in the 6th carbon. So you're gonna be 4,4 dimethyl 1,6, and I'm going to put it here because I have no space. It's gonna be 7 carbons, the prefix F, 2 double bonds, prefix D, and then in. So you're gonna in. Well, this is the name of this hydrocarbon. Okay, here we got another example of an alkene. If you see, this alkene has 2 double bonds. Okay, the first step to name alkenes is to identify the parent chain. Well, at first sight, it appears the parent chain it will be the more longer, but not. In alkene, we're going to choose that one that involves the double bonds. Even if this is more longer, this is gonna be a substituent. Why? Because here is the double bond and here is the other double one. So we're going to start naming the parent chain from the side that is more closer to the double bond. In this case, it's equal, but the substituent it affects. We're going to start naming from the side that is more closer to the substituent, more simple numbers. So we're going to start naming 1, 2, 3, and 4. Then here we have our substituent, and we're going to start naming our hydrocarbon, our alkene. Well, first is the substituent. Here we have 3 carbons, so the prefix is prop. So you're gonna be 3 propyl because it's a substituent, and then the numbers where the double bonds of the alkene are, and so it's gonna be 1 and 3. 1, 3. Sorry, here's 2 because it's in the carbon 2. Sorry. Propyl 1, 3 because it's 4 carbons. So you're gonna be but. because it has double bonds, we're going to put the prefix D, that is means 2, 3 for 3, and tetra for 4, and so on. But here we have two double bonds, so we're gonna boot, no, let's see, boot DN. So this is the name of our hydrocarbon. Okay, now that we learn how to name it carbons, we're going to learn to draw it. So we're going to start drawing carbons, not hydrogens. It's more difficult. We're going to start drawing carbons. So we're focusing on the last word that is identifying my parent chain. And because it penta, it means that it has 5 carbons, the longest chain or the parent chain. So I want to draw it 1, 2, 3, 4, and 5 carbons. Okay, this number gives me the location of the double bond, and this is the second carbon. I want to start from here, not from here. So I know now that the double bond is here, which is the carbon 2 and 3. Okay, then we're going to focusing on the substituent. The substituent is a methyl in the carbon 3. Here we have 1 carbon because it's meth, the perfect one, methyl, and the 3 carbon. Now we put the carbons and that's our compound or alkene. Here we got another example that is 3-ethyl 4-methyl 1,5-hexadiene. First we're going to focus on the name of the parent chain or the longest chain. Well, not the longest chain, the parent chain. It has the perfect hexa, so it's gonna be 6 carbons. 1, 2, 3, 4, 5, and 6 carbons. Okay. These numbers give me the location of the double bonds, and I notice that it has 2, and because of the number, the in. So in the carbon 1 and in carbon 5 we have double bonds, 1 and 5. 1, 2, 3, 4, 5. Yes, the 5. And then we're going to focus on the substituents. In the 4 carbon, 1, 2, 3, 4 is 1 methyl, 1 carbon, and the third carbon is the ethyl. 1, 2, 3, 2 carbons. This is bonded to this, so it's not from here. And then we put the hydrogens, and it's going to be H2H. This is H equal H2, H3, CH, H3, H, and H2. This is our alkene. Okay, here we have the last example, and here we're going to draw it. Okay, we identify the parent chain, heptadiene, that gives me that it has 7 carbons. 1, 2, 3, 4, 5, 6, and 7 carbons. The double bonds are located in 1 and 5. 1, 2, 3, 4, 5 here. And the substituent is an isopropyl, so it starts from the center, not from the sides. So it's gonna be in the third carbon, it's gonna be an isopropyl, C, and bonded to carbons. So, or we put the hydrogens, CH3, it has CH, this also is CH, this is also CH, CH2 carbons, CH2, CH, and CH and CH3. This is the drawing of our hydrocarbon or alkene. Thank you.
Okay, hi, I'm sorry for not being with you, but I have to do something. Now we are going to see about alkenes. Alkenes are there are like alkanes, but they're not composed by just like this. We'll see. Here we have the carbon. Well, you have seen that this is an alkane. This is an alkane that have a double bond, but we will see about alkenes. Well, here we have a double structure. We have two carbons and a triple bond. Well, we can see that. Well, let me write for you. If it would be an alkane, it would be thin, but this is an alkene, so this is thin. Well, we know that I'm going to be brief with this. We don't have the alkenes are similar to alkanes and to all the others. So we are going to be brief with this. Let me work. We'll see. Okay, pencil. No, pencil not. Okay. Well, you know. Also, we can have something like this, and you can say, whoa, what are we going to do with this? Well, this is it. We'll check our chain, that is this one, and we see that here we have a single bond and here a triple bond. Well, now we are going to write the name, and this would be like we have a single chain, so we have three that we know that it is an butane, but the triple bond is in the between 1 and 2, and one of the laws of the alkenes are that with the smallest number we begin with that bond, so it would be 1, 2. Okay, and I think that is all, because you know the chains are similar, but that is all. You will use the same examples, the same prefix, and that's all. Thank you.
Well, hello everybody. My name is David Garcia, group 215, and I'm going to teach you how to transform from formula to a name. Well, we have the first example. It is this formula. Okay, and then we draw it. Is CH2 CH3. The general formula from this is C6H5 CH2 CH3 from this one. Well, to know this, it is very easy. Well, as you can see here, we have two elements here, CH2 and CH3. So as we know, when we have two, it is an ethyl. It is ethyl and benzene. Well, it is ethyl benzene because we have these two, and here we have the general formula from this one. So that is how we transform from formula to a name. This is the name and this is the formula. Okay, this is the example number 1. Well, now the second example, we have this formula. Well, here we can see that in the left side we have H3C and in the right side CH3. Well, in here we need to put it the numbers. In this case it's going to be 1, 2, 3, 4, and so on and so on. We are not going to put numbers here because we don't have anything over here. So in this case, this formula to put the name, we know that here we have here and here. So we are going to put the first one. So it is 1, 4 dimethyl benzene. 1, 4 because we have in number 1 and in number 4. Dimethyl because they are separated and they are methyl but double. And benzene because we know that we have this formula over here. The molecular formula from this one is C8H10. So that is the second example from formula to name. That is called dimethyl benzene. Well, now the third example from formula to a name, it is going to be this one. Okay, we can see over here that we have these two lines and these ones. Well, first we are going to put the numbers. So in this case, we know that these ones are separated. So like we are going to put over here, it can be 1, 2, 3 or 1, 2, 3. So it is better to put 1 over here, 2 over here, 3 over here, 4 over here, 5 and 6. So when we have already the numbers, we are going to put the name of it. So in this case we are going to put 5-ethyl, 1,3-dimethyl, benzene. Well, over here we have already the name right here. Well, why we put 5-ethyl and why we put 1,3-dimethyl? Well, very easy. As you can see over here, and as you can see over here, it is very easy. These are methyl. So because we have 2, we are going to call D, that means 2, and methyl, that are just 1, and benzene also. And over here we put 5-ethyl because it has 1 line over here, as you can see it, and 1 line to the top. And why we put first one, when we put this one first, because the letter, we know that we have E, and then, well, this doesn't count, so we are going to put first one, the most important. Well, that is the third example from formula to a name, that it is called 5-ethyl 1,3-dimethyl benzene. And the molecular formula for this is C10H14. Okay. Well, I wish that you, with these 3 examples that we made, I wish that you learn how to do it. And now we are going to pass from name to a formula, and here we go. Well, hello everybody. Well, now we are going to do it from the name to formula. Well, in this case, we have the name that it is methyl benzene, also called toluene. Well, we know that we have the name and we have another name that it is common. Well, we were thinking how to do it. Well, we know that we have methyl, so we know, okay, we have methyl. So what we are going to do? Well, first we are going to make the formula. Well, to create the formula, we know that we have this one over here, okay, and we are going to make also the lines. So we create this one, we put that line, and we also put this one, okay, and also we put this one. Okay, very easy. We cannot put this one together or this one together. Now we need to have it separated so we can identify. Well, and we say, okay, benzene. Okay, we know that it is one, so we can put CH3. Well, that is the formula. This one is the formula from this name. This one is the first example that we are going to create from name to formula. I wish that you understand, because this example is just an easy example, and we are going to go harder and harder. So let's do the example number 2. Well, now we are going to create the example number 2, and in this case we have 1, 2, 3. We put a line to separate the numbers from what we are going to write. 3 from mine. Okay, we know that we have 3 from mine, and then, well, we need to add, so we need to add benzene. Okay, we have 1, 2, 3, the line, always remember the line. 3 bromine, 3, remember 3 bromine, benzene. Okay, with that we can identify better, or in case that you forgot something, well, we can identify. Well, in this case we are going to do the same. Okay, always remember in not putting a line over here. Okay, we put the line over here, and we are not going to put this one over here together. We never do that. Okay, we put the line, and we are going to remember to put it separated. Remember always to put it separated. Well, we know that it is 3, and 3 means like 3. Okay, 1, 2, 3. So, oh, okay, we are going to put it. Okay, we are going to put the numbers. Okay, this one is going to be 1. This one is going to be 2, 3, 4, 5, and 6. Or this one, 5. Okay, and we know that 1, 2, 3. Okay, 1, 2, 3. 3 bromine. Okay, Br. We know that the bromine, it has Br. So 1, 2, 3 bromine. Br over here and Br over here. Okay, and that is how you create name to formula. Here is the name, and over here we have the formula. Well, as you can see, it is very easy. If you don't remember something, it is very special to do this, so you can identify better. Well, in this one, the molecular formula is C6. Okay, C6H3 Br. Okay, we have C6H3Br, and what we are missing is 3, because 3 bromine. Okay, and that is how you create example number 2 from name to formula. Okay, everybody. Well, now we are going to make the third example from name to formula. Well, the third example from name to formula is going to be 1 methyl and then 9 3, and then as you can see over there, we have 1 methyl 3 propylbenzene. Well, over here we have already the name. After having the name, you are going to always remember to put the lines, because if you don't put the lines, you are going to get it wrong or something. So, why we put the lines? So we can identify that the number, the word, the number, the word. Well, over there we have also the lines. So we put the lines so we don't want it wrong. So we have 1 methyl 3 propylbenzene. Well, in 1 methyl 3 propylbenzene we have this formula. We create always this one, and then over here, and then well, we have that one, and we are going to put the line. So we put the line over here, skip the line over here, look, the line over here, and then skip this side, and then the line over here. So over here you are going to have it in this way. We have the line over here, and then in this side we are going to skip it, and then the line over here, and then we are going to skip it, and then the line over here and skip it. So that is the way that you are going to have this one. Well, in this case we are going to have this, this, and this, and then we have over here like this. Well, why we know that it is like this? So first of all, we need to put the numbers so we can identify that it is correct. So we put 1 methyl 3 propylbenzene. Okay, over here we are going to put it like as 1, and then we are going to put it over 2, 3, 4, 5, and 6. As you can see over there, we have already the numbers, and as identifying or checking the name and the formula, it is correct. So we have the 1 methyl, that it is over here, the 1 methyl, and then the 3 propylbenzene. Okay, we have the 3 propylbenzene over here. Well, as you can see, now we can identify is the name, and to create the formula, it is very easy. Well, I wish that you learn a lot with the 3 examples from name to formula, and the 3 examples from formula to name. Well, with these 3 examples, we can explain you like a little bit from these exercises, and I wish that you learn a little bit or learn more. I always think that chemistry is the better thing that you are going to have, and also think that chemistry, it is the best subject in the world. Thank you. Also, the chemistry, it is very interesting, so they name it the chemistry, it is the best one in the world, because it is the most interesting and the most problems that they have with solutions, that it is very interesting to learn this. So thank you very much.
Well, now that we have seen the other hydrocarbons like the alkenes, the alkynes, the aromatics, now we are going to see the new type of hydrocarbons, that are the hydrocarbon derivatives. The hydrocarbon derivatives are the type of compounds that have a change in one of the elements that is not a hydrogen. The type of hydrocarbons that we are going to change are called functional groups. And here we have 7 different functional groups that are the alcohols, the thiols, the ethers, the aldehydes, the ketones, the carboxylic acids, and the esters. Well, first I'm going to start with alcohol. The general formula of the alcohol is having a methyl group that I'm going to represent it with the letter R, and the compound in the compound of hydroxide. Well, an example of alcohol, it could be methanol. That it will be the methyl, that will be CH3 combined with the hydroxide. In here, this will be the functional group, the hydroxide. And for another example, we're going to make it a bit complicated. This will have a substituent. It will be a butane, that is 4 carbons. In this carbon, I'm going to put the hydroxy group, the hydroxide, and in this one, I'm going to put a methyl, and then we complete it with hydrogens. This compound will be called 3-methyl-2-butanol. Well, then the next functional group that we want to check is the thiols. The thiols is similar to the alcohol, just that it will be the alkyl group represented with R, and another compound that is the hydrogen sulfide. An example of this will be, and the name to call it is just to put the prefix of the number of carbons, and we're going to add ethyl at the end. The first example for the thiol, it will be the metanethiol. That it will be the methyl combined with the hydrogen sulfide. Well, here the main function it will be the sulfur hydro. And here now we're going to the second example. It will be the ethanethiol. That it will be the thing that is the key group and the sulfur hydrogen. Now the other one we are going to see is the ether. The general formula for this one it will be the key group, then the oxygen, and then the other alkyl group. An example, we have the ethyl methyl ether. That will be the ethyl, then the oxygen, and then the methyl. And for example, we will have dimethyl ether. That it consists of 2 methyls joined by the hydrogen, the oxygen. Sorry. Well, the next functional group that I'm going to explain is the aldehydes. The aldehydes, the general formula is by having the alkyl group, then we put a carbon joined with a double bond to a hydrogen, and we combine it with a hydrogen. An example of this one, it will be the methanol. That it will be the alkyl group. We put the hydrogen, then we put the double bond of oxygen and the hydrogen that it holds. Now, for a second example, we will do the ethanol. That it is made by first the alkyl group, that is the CH3. Then you put the carbon with the double bond of oxygen and a hydrogen here. Well, now the next one is the ketones. Its general formula is made by an alkyl group, the same carbon with double bond of oxygen, but now it will be combined with another alkyl group. Now, as an example of the ketones, I'm going to show you the do-propane-propanol. That it will be made by the alkyl group, that it will be the methyl, then the carbon with double bond of oxygen, and the second alkyl group it will be again the methyl. Here is. Now, as a second example, it will be the 2-butanol. Butanol. First, we're going to put a methyl with the carbon and double bonds, and as a second alkyl group, we're going to put the ethyl. So it will be CH2. Now, the next functional group, it will be the carboxylic acid. This one, the general formula for this one, it will be the alkyl group, the carbon with double bond, and then the hydroxide. Now, an example of this one, it will be the methanoic acid, and it consists of it starts with the hydrogen with the carbon and double bond, and the hydroxide. And for second formula, we will have the ethanoic acid, that it will have the alkyl group, the CH3, the carbon with double bond of oxygen, and the hydroxide. And at last, for our last functional group, it will be the esters. The general formula of the esters is made by having the alkyl group, then the carbon and double bond with oxygen, then it is joined by another oxygen, and this one is joined by another alkyl group. An example of this one will be the methyl formate. It will consist of first the hydrogen with the carbon and double bond of oxygen, then another oxygen, and the last we will put the methyl, CH3. Now, for second example, it will be the methyl ethyl for the methyl ethanate. Sorry. It will the alkyl group. We will have the methyl, then the carbon with the double bond of oxygen, then the oxygen that combines, and the methyl once again. And with this, we have done with all the hydrocarbon derivatives that we are going to show you.